All right, now that we have the fun of learning what moles are and how to calculate the mass of one mole, which again is straight off the periodic table, the average atomic mass, um, let's talk a little bit more about what a mole actually is. Now, like I said in the previous video, a mole is a quantity, a number, right? So for example, you all know that if you have a dozen donuts, that would be equal to 12 donuts. If the baker was nice enough to give you what's called a baker's dozen, then that is actually 13 donuts. You all know that the word couple means two. One ream of paper, which is usually, about this size, that's usually 500 sheets of paper. So those words, dozen, baker's dozen, a couple, sheets, all have a numerical value associated with them. And it's the exact same thing with a mole. A mole is 6.022 times 10 to the 23rd atoms or molecules or really anything for that matter. And this is what's called Avogadro's number, named after, dang, what's his first name? Amadeus? No. Gosh, can't remember his name. Sorry, it's been a while. Avogadro's number is named after him, of course, and he came up with this concept of 6.022 times 10 to the 23rd atoms. So what we need to do now is learn how to convert, do basically like vector conversions, but we're dealing with atoms and particles and molecules and moles, but it's all basically the exact same process. So let's go ahead and try a couple of these together, and I'll explain as we go as usual. So the very first one we have here is find the number of moles in 162 grams of silver. Dang it, I forgot my periodic table and my calculator yet again. So hold that thought one more time, guys. It has not been a very good day for me when it comes to being prepared for these videos, but bear with me. All right, so back to the question. It says, find the number of moles in 162 grams of silver. So whenever you have a question like this, you always start with what you are given. We are given 162 grams of silver. Make sure you label the unit, grams, and the element silver. Please do not get lazy, because trust me, this is going to get vastly more complicated in the next unit. And so you really got to build your good habits now so it doesn't come back and bite you later. So what we're going to do is we're going to multiply by a conversion factor or a fraction. Notice we have grams to begin with, so we have to put grams down here because, of course, when you have a number on the top and something on the bottom, they cancel out. That's going to cancel out our grams. And what we're trying to get to is moles, M-O-L-E-S, or just M-O-L for short. So what this is going to be right here is what's called a molar conversion or molar mass. We learned about this in the previous video. We know that for every 1 mole would be the mass of silver off the periodic table. So the mass of silver is 107.868. So that's the mass of the average atomic mass of silver, which again is the mass of 1 mole of silver. So when we do this, we're going to cancel out, oops, that was supposed to be a cancel out grams, those cancel out, and what we're going to be left with is some number of moles, and that's going to be our answer. All I need to do now is get my calculator. What I'm going to do is do 162 times 1, which yes, I know is redundant, and I don't need to do that, but let me just go ahead and say it because I'm going to multiply the numbers on the top, and then I'm going to divide it by the number on the bottom, which is 107.868. And my final answer is 1.5. I can't even see it. 1.50. I'm going to round that 1 up to a 2. 1.0 or 1.502 moles of, silver. There we go. So again, basically the way that this layout works is I'm going to go down to cancel out first, and then we convert as we go up. That's a pattern you're going to see over and over and over as we do these problems. The sooner you see it, the better it'll be off. Number 2, how many moles are contained in 1.50 times 10 to the 12th atoms of lead? So we're going to start with the only thing we're given in this problem, which is 1.50 times 10 to the 12th atoms of lead, which is Pb. Then we're going to multiply this. Again, we need to cancel out atoms of Pb, so I'm going to put atoms of Pb here. And then they want to know moles. We can go directly to moles of Pb. The reason is we know the conversion of how many atoms there are per mole. We know that because it basically tells us right here. There's our atoms of per mole. So the atoms down here would be this right here, 6 point, oops, that's not a point, 0.022 times 10 to the 23rd atoms is equal to 1 mole. Okay, then again, atoms of lead will cancel out. What we're going to be left with is some number of moles of lead, and that's going to be our answer. Let me get my calculator. It's going to be 1.50 times, oops, second E 12, if you guys remember that from previous units, times 1, which is the same thing, divided by 6.022 second E 23. All right, what I get is 2.49, round that up to a 1, times 10 to the negative 12th. All right, so that is the number of moles of lead. The reason why that number is so small, times 10 to negative 12, is a very, very, very small number. And that's because we don't have a whole lot of atoms of lead here. So it's not going to be a lot of moles. It's much less than 6.022 times 10 to the 23rd. So it's not surprising. Our answer is a very, very small number. Again, what I want to point out to you guys is the pattern. It went from atoms of lead to atoms of lead. Then we converted up into moles of lead. Okay, again, this part is doable as long as we know the conversion of moles to grams or moles to atoms. And again, we do because of this information there. All right, let's go ahead and try the next one. Number 3. Number 3 says that we have 18.6 grams of iron, Fe. We're going to multiply, put grams of Fe down here to cancel it out, and they want the number of atoms. Now, I can directly go into atoms, but I'm going to go ahead and show you guys the long way. It's not much longer, but just bear with me, of iron. Now, when I do that, iron's going to cancel out, but we don't want moles of iron, so we're going to put moles of iron down here, and then we're going to have atoms of iron. Now, the reason why I'm going to do that is because moles will cancel out, and we'll be left with a number of atoms of iron, and that's going to be our answer, of course. But remember, like I said before, we could only do this if we know the conversion of grams to moles. Well, of course we do, because that's called a molar mass. For every X number of grams is 1 mole of iron. And we also know the atoms per mole, because 6.022 times 10 to the 23rd atoms is how many atoms of anything are in 1 mole of that substance. So those are 2 conversions that we do know. Therefore, we can do this conversion as written. Otherwise, if we didn't know those conversion factors, then obviously we wouldn't. So for every 1 mole of iron is going to be equal to, let me look at my periodic table, 55, again, this is just molar mass, everybody, 55.845 grams of iron. So 1 mole of iron is equal to 55.845 grams of iron, says it so right there. Then on the next part, we're going to do atoms. We know that 6.022 times 10 to the 23rd atoms of anything is equal to 1 mole of that thing. So now that we know all this, again, we're going to go ahead and pick up my calculator. I'm going to do 18.6 times 1 times 6.022 second E 23. Then I'm going to divide that by 55.845. I'm just dividing by everything on the bottom. And again, I divide by 1, but of course it's going to be the same thing. And my final answer is, I'm going to have to put it over here to give me some space, 2.00, I'm going to round that up to a 6, times 10 to the 23rd atoms of iron. There's our answer. Again, notice the pattern. This goes to this, cancels. Then we convert up. Then when this goes down to that, that cancels. And then we go up. What we're left with is atoms. Notice that zigzag pattern is always what we're going to be doing. Now, like I said, this is kind of the long way. And the reason I say that is because, honestly, I could have left all of this out and just put atoms above grams. Now, I didn't want to confuse you, even though I know many of you guys are probably already confused, but I did not want to put atoms above grams because I want you guys to see that really we were going from grams to moles and then from moles to atoms. But now knowing that, I literally could have just put that above and simplified it a little bit. I would have got the same answer, right? But I still want you guys to see it. All right, that being said, guys, let's go to the next one. The next one we have here is how many grams are contained in, come on, go away. How many grams are contained, let's go away. Oh my gosh, how many grams are contained in 3.02 times 10 to the 23rd molecules of carbon monoxide, or CO? Okay, so the only number we're given is 3.02 times 10 to the 23rd molecules, and unfortunately there is no abbreviation for molecules. A mole is not a molecule. A mole is a quantity. A molecule is a compound, an organic compound, or a covalent compound, excuse me, of CO. Okay, then we're going to convert that. We need to get rid of molecules. So I'm going to put molecules down here. Notice that I always put my units first. I'm not even worried about the numbers right now because I highly recommend you guys get the units and your pattern correct, then go back into the numbers. Trust me, it's a lot easier. All right, so then molecules, we need to go into, I don't know how many molecules are in our, however many grams, so we need to go into moles first. The reason we need to go into moles first is because a molecule of iron phosphate is a lot heavier than a molecule of, say, oxygen gas. So I cannot just go from molecules to gram because that is totally different. We have to do a normalization of going through moles because if we go from molecules of carbon monoxide into moles, then we could figure out grams because again, a mole of iron phosphate is way heavier than a mole of carbon dioxide or carbon monoxide. So we need one more step. I'm going to put mole of CO to cancel that out. And then we're looking for grams, and we can go from grams and moles of carbon monoxide. That again is just the molar mass. So this will cancel, that will cancel. This will cancel with this. And of course, our answer will be in grams of carbon monoxide. All right. Again, notice the pattern, molecule, molecule, up to mole, down to mole, up to gram. Okay. So now let's go ahead and put in the numbers. So for moles, for every 1 mole is 6.022 times 10 to the 23rd of anything. That includes carbon monoxide. That again is just a standard. The next one we have over here is for every 1 mole of carbon monoxide, we would have the molar mass. Okay, well, molar mass. We have carbon monoxide, we have a C and we have an O. Carbon is 12.999. No, it's not. Scratch that. 011. Oxygen is 15.999. If I add those together, because there's only one of each, 12.011 plus 15.999. The molar mass of carbon monoxide is 28.01. So I'm going to put 28.01 right there because the mass, 28.01 grams of carbon monoxide, is automatically and always equal to 1 mole. All right, let's go ahead and calculate this. 3.02 second E23 times 1 times 28.01 divided by 6.02 second E23 and then divided by 1, which is the same thing. My final answer is 14.04 and round that up to a 7. There we go. That's the number of grams of carbon monoxide if I was to hold on to 3.02 times 10 to the 23rd molecules of carbon monoxide gas. It would actually weigh 14.047 grams, which again is kind of surprising because that's a gas, but gases do have mass. They're just very light. All right, number 5. It says calculate the number of molecules contained in 3 moles of water. Okay, so the only thing we're given to start with, let me go ahead and clear this out real quick. We may need that space. Okay, so we have 3 moles of water. And we're trying to get to molecules. So we need to put moles of water down here because we need to cancel out, right? what we start with, we always put to the bottom right to cancel. Now from moles into molecules, that is something that we do know the conversion factor for, because again, that's Avogadro's number. So I could do a direct conversion, which is nice. I like when it works like that, because I know that for every 1 mole of water is 6.022 times 10 to the 23rd molecules. So moles will cancel out, and what we're going to be left with is molecules of water. Now remember, a mole and a molecule, just to repeat, are not the same thing. A molecule is a compound, in this case H2O. A mole is a quantity of water molecules. Totally different, even though it has the same root word. Do not get lazy and assume they are the same thing, because they are not. All right, so 3 times 6.02 second E 23 divided by 1, just for completion and correctness, I get 1.80, round that up to a 7, times 10 to the 24th. That's how many molecules of water are in 3 moles of water. Okay? The next one, number 6, which says calculate the number of moles of 2.00 times 10 to the 16 molecules. Again, do not get lazy, write out the word molecules, of sodium hydroxide, NaOH. They both have a charge of 1. Na is 1, hydroxide is -1. Cross them, it's just NaOH. All right, then we're going to convert that. I need to get rid of molecules, so molecules, NaOH. That is really sloppy. Sorry about that, guys. Having to write on a vertical board while you're holding your pen like this is not easy. We're trying to go to moles. Now, luckily, again, we know the number of moles per molecules because, again, we did it on number 5, and it is a constant. It is Avogadro's number. So we know that for every 1 mole, it is 6.022 times 10 to the 23rd of anything. So molecules of sodium hydroxide will cancel out. We'll be left with moles of NaOH, sodium hydroxide. So I'm going to go ahead and put 2.00 second E 16 times 1 divided by 6.022 second E 23 equals, ooh, that's really small, 3.3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 to the -8. That's how many moles of sodium hydroxide are contained by 2.00 times 10 to the 16th molecules of sodium hydroxide. Okay, I'm gonna go ahead and push forward because again, I don't want to make this video any longer than it already has to be. So number 7, oops, sorry guys, kind of jumping around a little bit. All right, number 7, what we have here is calculate the number of moles. Again, the only number we're given is what we're going to start with, 2.00 times 10. Oh, we just did that one. Sorry, guys. Scratch that. Number 7, calculate the mass of 1.20 times 10 to the 25th molecules. Man, not very fun to write out molecules, but honestly, is it hard? No. Okay, F2. We're going to put molecules down here because we have to cancel it out, right? F2. Oops, not iron. Wrong element. Okay, and then we want to do the mass. So again, we cannot go directly from molecules to mass because molecules of fluorine is going to be entirely different than molecules, or the mass is going to be different than the molecules of, again, iron phosphate. So we must go through moles first because that will normalize everything. Then we're going to have to get rid of moles. So MOL or MOLES, same thing. And then we can go into grams of F2. Okay, now that we have that, molecules will cancel out with molecules, moles will cancel out with molecules, and our molecules, and our answer will be in grams of F2. Now that we have the units, they all cancel out, everything looks good. Now we go back and do the numbers. Trust me, again, it's easier that way. Do not do the numbers as you do the units because you'll get more confused. We know that for every 1 mole is 6.02 times 10 to the 23rd molecules of that substance. Again, it doesn't matter if it's iron, doesn't matter if it's fluorine, doesn't matter if it's iron phosphate. 1 mole of anything is equal to that many molecules. Okay, that is a constant. Over here, we know that for every 1 mole is going to be the molar mass off the periodic table. So fluorine has a mass of 18.998, but it's F2, so it's times 2, because that's what fluorine is. So then therefore, again, let me do this, 18.998 times 2 is 37.996 grams. 37.996 grams is equal to 1 mole. So 1.20 second E 25 times 1 times 37.996, oops, 996 divided by 6.022 second E 23 times 1 equals 74 point, oops, no, that's not right. Wow, I'm totally wrong. I don't even know where I got that number from. 757, wow. Just a little off, right? Just a little bit. There we go. That's the number of grams contained of iron, fluorine, in 1.20 times 10 to the 25th molecules of F2. All right, so that's 1 through 7. They're definitely not easy, but you guys should notice a pattern. Again, the pattern works like this. It zigzags down, then you convert up. Zigzag down, then you convert up. Again, excuse me, as you go vertical, the conversion has to be something that you know, like molecules to moles, grams to moles, or vice versa, moles to grams, moles to molecules. But you cannot go directly from grams of something to the atoms or molecules of something, because again, every compound, every element has a different mass. You must go through moles in order to get there. All right, number 8 is going to be significantly harder. So I want to show you guys something like this, because you are going to see something like this on the practice I'm going to give you guys, because I'm evil. So let me go ahead and show you how to do number 8. All right, number 8. Let the fun begin. What we have here is 1.55 grams of tricarbon octahydride, which is propane. That's propane. Okay, so we're going to calculate the number of hydrogen atoms, not just atoms, but specifically hydrogen atoms in that molecule. So what we need to do is we need to go and cancel out our grams. Okay, first things first. Then we're going to go to moles, because again, we know how many grams of this are in any mole. How do we know that? Because we know molar mass. Okay, when we do that, we're going to have to do another step, and we're going to go from moles of C3H8 into moles of hydrogen. Okay, we're splitting from the C3H8 into specifically just H. Finally, we're going to need another step. So we're going to cancel out moles of H, and then we're going to go into atoms of H. Okay, again, grams of C3H8 will cancel out. Moles of C3H8 will cancel out. Moles of H will cancel out. What we're going to be left with, not surprisingly, is atoms of H. So that's going to be our answer. So again, there's the pattern: diagonal down, convert up, diagonal down, convert up, diagonal down, convert up. You guys get the idea. Now for the first conversion factor, we know that according to the periodic table, for every 1 mole of anything is equal to its molar mass. So let's calculate the molar mass of C3H8. So we have C and we have H. C is 12.011. There are 3 of them. H is 1.008, and there are 8 of those. So 12.011 times 3 equals 36.033. Sorry, my pen is messing up a little bit. Not sure why. And then we have 1.008 times 8 equals 8.064. I'm going to add those together because that's what molar mass is. 36.033 equals 44.097 grams. So I'm going to put that right here. 44.097 grams. Now that we got that, we're going to do the next one, which is the molar conversion from moles to moles. So for every 1 mole of C3H8 is equal to 8 moles of H's. So 1 mole is 8 moles of H's. Why? Because of this. That's where this comes from, okay? So if I have 1 mole of propane, C3H8, I actually have 3 moles of carbon and 8 moles of hydrogen. So that's where this number comes from, okay? All right, now to continue on, in our last one, we know that for every 1 mole, we have 6.022 times 10 to the 23rd atoms. Sorry, guys, I'm trying to squeeze things in a little bit. So let me get my calculator. 15.5 times 1 times 8 times 6.022, second E, 23, divided by 44.097, divided by 1 equals a grand total of 1.693 times 10 to the 24th atoms of hydrogen. Whew. All right, there we go, guys. That's how to convert the mass of a compound into the number of atoms of a specific element in that compound, okay? Now, I know this video is very dense. Your brains are probably oozing out of your ears at this point, and I understand, but you may need to watch this a second time. But again, what I do want to stress to you guys real quick before I stop is remember, whoops. Oh boy. Sorry about that. Like I said, it's been not a very good day for video making. What I want to remind you guys is that this part right here, again, Avogadro's number is that many atoms or molecules or anything is equal to 1 mole. Now, 1 mole is equal to whatever the molar mass is. But again, you cannot go directly from atoms of one thing into grams of something else, but we'll get to that later. But anyway, guys, so like I said, please watch this video a second time or torture yourself and watch it a third time. But regardless, you need to understand this because when we get to the next unit, we're going to add many, many layers on top of this. So you guys really need to understand what we just went through, okay? All right, guys, as always, thank you so much for watching, and I hope you guys have a good evening.